My name is Stephan Ritter. I work for TOPTICA Photonics, a laser company based in Munich, Germany. And I started there about 6.5 years ago. Before that, I was a long-term researcher working on quantum networks with single atoms and optical cavities, Bose-Einstein condensation, so several quantum technology related research applications. TOPTICA is a laser company, and lasers are employed for many different tasks in the quantum simulators to be built in PASQuanS and to be developed further. And we are really working on these lasers to match the requirements that are there. There's one specific topic that we work on here, and there are several aspects, which is frequency stability of these lasers. For those lasers that stand out because they are typically rather narrow line width, it's very important that the frequency of these lasers is exactly controlled. And we do that basically on we work towards that on two time scales. One of those time scales is kind of like short term. We have in PASQuanS 1 started research on a module that you can use to frequency stabilize one of those lasers with respect, say, to another one or some other frequency reference. So we call it an offset lock module, and what we basically do there is that generating an error signal from two lasers by overlapping light from them, we generate a signal that then can be processed through this electronic module in order to generate feedback onto the laser that's to be stabilized with a variable frequency offset. You can do jumps, you can do frequency sweeps, and that is something that we are kind of continuing here. PASQuanS is a consortium with world-leading players, and I think in the consortium we are making progress on so many different layers. And regarding really industrial applications, I think there's others who are more competent to talk about that, who are closer to the applications of these quantum simulators. What I can talk about is that we are advancing the enabling technology that's to be used for PASQuanS, and there's spillover into other areas of quantum technologies as well. These things that we develop can also find uses in, say, quantum communication, quantum computation, also in sensing. And so while it is specifically targeted and we work in close collaboration with partners in PASQuanS and we are looking at their demands, it will help to create technology that can be used at a broader footing. I think it's great that in this project, industry and academics are being put together to make use of the competencies of both worlds. I've been playing in both worlds, so I kind of know the two sides. There's one interesting aspect, and that is the flexibility that you have and that you need to have, which differs a little bit in the two fields. So as a researcher, if you do, say, experimental things, you do an experiment once or maybe twice to confirm it, and then you have your data, you've learned what you want to learn, and you move on to do the next step. For us as a company, if we've done a one-off, that's only the starting point. What we are aiming for is to create a product that we can then build many, many times in an extremely reliable fashion. And that means that we have to plan ahead more, that we plan really a lot, and we also are less flexible in a way because we have to follow some path that we are going, whereas the academics, I think, are a little more flexible in adjusting to that. So these are two worlds that need to be brought together. I think what we have in PASQuanS is a deep understanding of how the other side operates, and in particular, for me now coming from industry, we are really interested in serving this community. And if there's new evidence that something is required in a different way, that there's new methods, then we are super eager to learn about them firsthand. Right, those are regulations that we obviously have to and do follow. It's a pretty political question, I'd say, going into that in more detail, and I think people dealing with this topic kind of regular from the political side can judge the arguments better than I can. There's one thing that I can mention though, and that's that the EU alone for a company like TOPTICA would be a market that is too small, because our products are so tailored at the applications that we are serving, like the one in PASQuanS. So it is challenging if this market gets reduced. That's something that needs to be kept in mind. And so from a general kind of advancement of fields perspective, I think we have done really well in collaborating with partners all over the world, and it would be great if we could continue doing that, notwithstanding that there's political issues in the world that need to be considered.